Good afternoon, everyone. So before I start, I would like to ask you a question. What comes to your mind, a word which starts with R, when I say circular economy and hazardous waste? Can I have some volunteers, please? One word which starts with R.
Recycle, reuse.
Any more?
Reduce.
Great. So we have three words already. Reduce, recycle, and reuse. Or I should place it in another way. Reduce, reuse, recycle. I give you another word on that, that's reform. And reform is what we need in the lubrication practices across all the user-based industries who are using the lubricants today in the world. So let's start with power plants, specifically thermal power plants, hydropower plants, gas-based power plants, who are one of the top users of lubricants, various types of lubricants. So this presentation today would be specific to usage of power plant lubrication and reliability in this. So we are all aware that most of the expenditures which come up across for mechanical maintenance, it's somewhere related to the lube failures and lubrication failures, which can be certainly reduced to around 25%, and we can reduce the 80% of our maintenance expenditures if we reform our lubrication practices in various industrial sectors. We all talk about reliability and maintenance, and many times reliability speaks about vibration analysis, thermal analysis, ultrasonic analysis. But how many of us do speak about lubrication analysis? If you see this graph on the left-hand side, we can see it's a failure identification graph, which is a timeline. So you can very easily identify that the closer we are towards the breakdown, we are able to identify smoke, we are able to identify heat, noise, then comes the infrared or vibration, and lubrication analysis is one of the foremost analysis which can be done at the very initial phase, and by which we can identify a future failure in our lubrication system. If we talk about the significance of lubrication in power plants, there are almost 5 departments where lubrication is used in bulk. The first one, the foremost one, is the turbine maintenance, then is the boiler maintenance, coal handling plants, electrical maintenance, and the ash handling plant. According to the prime OEMs, they also have specified certain operational practices and operational parameters for the quality of lubrication in service. We are all manufacturers of lubricants out here, and we do have standard specification sheet data for lubricant which is coming out of our factory from the blending plants. But the properties and the parameters of lubricant, which are physical parameters, which are to be maintained during the in-service life of the lubricant, they are defined by the OEMs or the application engineers of those machineries which are lubricated by our lubricants. So these parameters are very important to be maintained. One of these oils in a power plant, which I would like to speak about a lot in detail in this presentation, is the fire resistant fluid or phosphate ester. It's a synthetic fluid which is based out of PE, phosphate ester, and that's one of the costliest fluid which is used in the power plant today, and one of the biggest concerns for almost all the maintenance engineers in thermal power plants of the country. So this particular oil, it catches contamination very fast because it's hygroscopic in nature, and due to its nature, it can start having some acid formation, that is increment of tan values in the particular oil. And as it is used in the critical governing system of a turbine, it's very important and critical that the properties, the lubrication properties of this particular synthetic fluid, they are maintained 100% of the time, that's a 24/7. So acid number in FRF, fire resistant fluid, it's one of the most important parameters to be maintained, and during our study and observation across the country, across the globe, we have figured out that tan value increase is the biggest headache of almost all the maintenance engineers across the globe. So what are the problems identified across the globe around tan value increment is that they have control valve hunting problems and improper governing of the turbines. What are the risks involved? as we understand, the turbine governing system is one of the most important parts or the components. The control valve, which actually defines how much of steam will enter into a turbine, and thereby you can synchronize a particular turbine. So that's one of the most critical parts of a turbine operation. And the oil, the fluid, which is actually the cause of operation of these control valves, if that itself is malfunctioning, of course, the entire turbine will go on a shutdown, and you would have to take a critical breakdown for your power plant. So what is the solution? So at the company Minimac, we have formulated a solution which is a 4-pronged solution which can take care of 3 different types of contamination. The first is the solid particulate contamination, the second is moisture contamination, and the third one is the tan value contamination. We are ensuring out of this system that we completely remove the moisture from the system by creating a dry environment in the headspace of the tanks which are housing the entire oil. So this is the inert gas blanketing system which we offer as a part of this particular product. This will ensure that dry inert gas is blanketing the top surface, the headspace of the tanks which are carrying the critical fire resistant fluid. We have some beautiful results which, this is the latest result from one of the power plants of India, where the tan value had shot up to 0.62 levels. Now for those who could see in the previous slide, BHEL has already recommended the max tan value around 0.2. So anything beyond 0.2 is considered as very, very big problem for them. So the value had shot to 0.62, which is 3 times the recommended threshold for the tan value. So our team used these purifiers and these conditioners to reduce the tan value over a period of 2 months and bring it down to below 0.1 level, to be specific 0.08 level, which is something which is as good as a new lubricant. The second problem, the second case study which I would like to discuss here is with regards to ingress of water contamination into the lubrication system of turbines. We are aware that there is a gland seal leakage failure in multiple turbines, steam turbines in the country, which are of a specific design. Now overnight we can't change the turbine design, so of course the best thing we can do is we can avoid the moisture ingress and we can avoid the moisture accumulation in the MOT, the main oil tank of the turbine. So for this we have an innovative system known as the coalescer separator. A lot of us would have heard about centrifuges. Centrifuges do reduce water in a big way, but these are costly systems, quite classical in nature. The technology is quite outdated. So we have come up with coalescer technology. I would just go on to the video to show how water is being separated using this coalescer. This is again around 500 liters of water which is separated on a daily basis. And this is a live video I got from the site today. It's another NTPC site where this coalescer technology is in operation. Varnish is a big concern today and a lot of people talk about it because varnish in gas turbines, steam turbines, hydraulic systems, these tend the entire hydraulic or lubrication component having a sheen surface over it, and because of which a lot of failures around bearings have been reported. So we have come up with a technology. I would show the case study out here. This technology is with regards to removal of varnish from the system. So this is a plant of India where we reduce the NAS value and varnish from a NAS 10 level to NAS 5 level, and the varnish was reduced to below 15 MPC levels. And this was done in a very short time, around 1 week. Another case study is from a power plant which is an Indo-Japanese technology. Here again, the condition was that the turbine fire resistant fluid, the critical control oil, the value had gone beyond 1.8, the tan value, and we reduced it to below 0.2 levels. Another case study from a Chinese technology turbine where the initial tan value had shot to beyond 0.8 levels, and it was brought down again below 0.1 levels. And this is the third case of control fluid, wherein again the tan value had shot up beyond 0.9 levels and brought down to 0.1 or 0.01 levels. Some of the credentials of our organization, various power plants where we have been operating and offering our systems. And these are the various clients where we have operated. So before ending my presentation, I would just like to say that circular economy is certainly achievable if all of us together can have a good intention around it. Specifically the service providers like us. Then the second is the lube companies. A lot of you are from the lube companies. If you can start having value-added services for your clients and you can start promoting the concept of no oil change. Certainly it's the conflict from the previous speaker's theme. But this is what we are promoting. If we can have a better practice, if we can reform the overall method how we are handling the lubrication systems in our plants, we can certainly achieve reduction in the usage of lubrication, and thereby we can achieve the first protocol of hazardous waste management and achieve circular economy very soon. Thank you very much.